Hello, welcome back. In this video we'll discuss the physical vapor deposition and the chemical vapor deposition techniques. Generally, vapor deposition refers to any process in which a material in its vapor state is condensed through condensation or chemical reaction or conversion to form a solid material. There are two major vapor deposition methods. They are the physical vapor deposition method and the chemical vapor deposition. In physical vapor deposition process, the material is bombarded with plasma, whereas in the case of chemical vapor deposition method, thermal energy heats the gas in the coating chamber and drives the deposition reaction. In the case of chemical vapor deposition, a chemical reaction takes place, while in the case of a physical vapor deposition method, no chemical reaction would take place. It is only a deposition of the material on the substrate. Now we shall look at the physical vapor deposition technique. For short is called as PVD. There are different methods of physical vapor deposition in use. The methods are evaporation, sputtering, laser ablation. However, in our syllabus we have the evaporation method, so we shall be discussing the evaporation only. In the evaporation method, the substrate is placed inside a vacuum chamber. In the same chamber, we will also have the source of material which needs to be deposited. The source material is then heated to the point where it starts to boil and evaporate. The vacuum chamber is required to allow the molecules to evaporate freely in the chamber. Later on, these vapors they condense on all surfaces. This principle is the same for all evaporation technologies. Only the method used to heat the material or to evaporate the material differs. There are two popular evaporation methods. The first one is resistive evaporation. Here you can see the resistive evaporation of materials in a glass chamber. You see you have a glass bell jar, you have a substrate table and a crystal detector here, substrate holder and sample. This is a substrate holder. What is a substrate? Substrate is a material on whose surface some other material can be grown. It could be a crystal or it could be a thin film. We have the path for the vapor in this direction because the entire thing is evacuated. Any vapor that is released by the material would eventually move upward. We have the filament boat filled with evaporant. This is a filament boat. This is filled with the evaporant, that is the material whose thin film we are trying to deposit on the substrate. Using the vapor deposition techniques, one can develop nano layers on the substrate, or multiple layers of nano materials can be developed on the substrate. The resistive evaporation is carried out in an evacuated bell jar. The material to be deposited is taken in a crucible. Here you have the crucible around which a high resistance wire is wrapped. A filament, that is the high resistance wire, that is wrapped around the crucible. When a current is passed through the wire, it heats up the material and vaporizes it. And these vapors they move upward and they deposit on the substrate. In some cases, the vapors are allowed to pass through certain gases to cool down the vapor such that deposition can take place on the substrate. The advantages associated with vacuum deposition process are high deposition rates and economy. Next we shall see the E-beam evaporation. In E-beam evaporation, an electron beam is aimed at the source material, causing local heating. In the case of E-beam evaporation, a beam of electrons are used to heat the source material. As stated earlier, the difference between them is only the way we rise the temperature of the material. In resistive evaporation, a tungsten boat containing the source material is heated electrically with a high current to make the material evaporate. While in the case of E-beam evaporation, a beam of electrons are used to heat the material locally. You can see this is the target material. We have the vacuum chamber, we have the electron beam, you have a magnet. This magnet will make the beam to rotate, and you have a shield here. Vapor goes upward. The target is here. You have the water line to cool down the filament. We have the tungsten filament. When the tungsten filament is heated, it emits the electrons, and those electrons, due to the presence of magnetic field, they will be deflected in such such a way that they start hitting the target material. Once the target material is hit by the electrons, the vapor of the material is liberated, and this vapor moves upward and gets deposited on the substrate here. That is how the E-beam evaporation works. Now we shall discuss the chemical vapor deposition, for short known as CVD. Chemical vapor deposition is a well-known process in which a solid is deposited on a heated surface via chemical reaction. In the case of chemical vapor deposition, a chemical reaction is involved. A solid is deposited on the heated surface via a chemical reaction. So a chemical reaction is involved in the case of chemical vapor deposition method. The apparatus looks like this. We have certain gases that are pumped into the chamber. We have a vacuum chamber here. So vacuum exhaust would come out from here and also from here. There are two outlets and you have two heating elements. You have the substrates there. Silicon wafers are used here as substrates. You have an electrode on top and the bottom also we have the electrode somewhere here. Due to the presence of a heater here, the temperature of the substrate would go up and heated to a temperature between 350 to 800 degrees. In this, one or more gases are admitted into the chamber through this inlet that would cause a medium pressure within the chamber. A reaction between the gases takes place in the chamber. After the reaction, newly formed molecules, they adhere to the wafer surface and participate in the formation of a nanolayer. These gases that are entering will undergo a chemical reaction and they deposit on the silicon wafers that are heated up by the heater. This is how a chemical vapor deposition chamber works. In this video, we have said that vapor phase deposition essentially is used to construct multi-layered nanostructures. The vapor phase deposition techniques are broadly divided into two: the physical vapor deposition and the chemical vapor deposition. We have started our discussion with a physical vapor deposition, which is also called for short as PVD. In PVD, the material should be transformed into a vapor. Vapor can be produced by evaporating, by means of sputtering, or by means of laser ablation. We have discussed only the evaporation method. We have discussed two different evaporation methods. The resistive evaporation method, where a filament boat is filled with the evaporant and the filament is supplied with external electrical energy, because of which the material would evaporate. The second method we have discussed is E-beam evaporation, where a beam of electrons bombard the target material to develop the material vapor. This vapor deposits on the substrate to develop the multi-layer nanostructures. We have also seen the chemical vapor deposition method. We have said a chemical vapor deposition method involves a chemical reaction. We have seen the chemical vapor deposition chamber. Thank you.